So we are asked, is this series convergent or divergent? We're not asked to find a sum. Now, when you have these really weird series that go from blah to infinity, are they convergent or are they divergent? Now, understanding the convergence of one doesn't necessarily tell you the sum. You need to make a formula that finds the sum of these. Now, this doesn't follow any of the series we've talked about, the harmonic series, the telescopic series, the geometric series, the p-series. This one can't simply be done with our knowledge. What we'll notice is that we can do a simple test. We can do the divergence test, then we can do the integral test. The divergence test, what is that going to say? Well, that's the first one we should do. Alrighty, so for the divergence test. Oh, how am I forgetting? Okay, we're going to have to take a limit of our function. If it approaches 0, it is indeterminate, and we have to do another test. If we get anything above 0, well, then we know it's divergent, okay? Because it's always going to go to, it's going to keep adding that number over and over and over and over and over. It's not a convergent sequence. That's what the limit is going to say. So we're going to take the limit as n approaches infinity for 2 over 3 plus 5n. We're going to notice that it's going to be 2 over infinity. I don't care about adding 3 or adding 5 times infinity. It's always going to be infinity. So this is going to be 0. The divergence test tells us that this is indeterminate. It could be convergent, it could be divergent. We just don't know. If we had a number other than that, we'd say divergent. Okay, moving on. Okay, but that's not the case here. All right, so we are indeterminate by the divergence test. Now we're going to do something called the integral test. The integral test says, okay, instead of saying this is a series, let's put f of x is equal to 2 over 3 plus 5x. Let's rewrite our series as a function. Let's now take the integral of that function. F of x equals the integral of, and we need to have our starting index to infinity. So this is going to just be an improper integral problem. So this is 2 over 3 plus 5x. I'm going to pull the 2 out. So this is going to be 2 integral 8, 1 over 3 plus 5x. You should notice that this is going to be a natural log function, but let's do u sub to determine that. So u is going to be 5x plus 3, where du is going to be 5. We notice we have a 1, so du really has to be 1/5 du equals 1. Okay, hopefully that idea makes sense. This is just basic calculus 1. I'm going to continue here. So we have 2, 2 over 5, 1 over u, du. Now I should have put dx here, but I'm a little lazy, you know. That's just who I am. I apologize. Notice that this will just be, because 1 over u, the integral of 1 over u is ln u. ln of u, in this case, is 5x plus 3. This is a definite integral, so we're integrating from infinity to 1. Now, remember, for improper integrals, you can't actually evaluate at infinity, so we have to rewrite this and take a limit. So we're actually going to say, and I'm going to bring this work up here, and if you don't believe that this is our integral, just take the derivative. This one's a little simple. We're going to say 2 times 5. This is going to be derivative over function, so it's 5 over 5x plus 3. 5's cancel, 2 comes over. We get our initial function here. Okay, so instead of saying, okay, 1 to infinity, let's say the limit as x approaches, or sorry, b approaches infinity for our function 2 over 5 ln 5x plus 3 evaluated from b to 1. Okay, I'll go ahead and erase this work to make some room. But you should notice that now we have the limit as b approaches infinity, but we don't have it in terms of our upper bound being infinity, it's just b. All right, so now we're allowed to say, okay, let's do the upper limit evaluation minus the lower limit evaluation. So this is going to be 2 over 5 ln of infinity, so this is 5, or of b, plus 3. This is going to be subtracted by 2 over 5 ln of 5, because 5 times 1 is 5 plus 3. So this is going to be ln of 8. So what can we say when we evaluate this term as the limit approaches infinity? Well, we know this is going to be infinity because the natural log of 5 times infinity plus 3 is infinity, times this term, that's also infinity, minus 2 over 5 ln 8. Well, I don't care about that. I'll just put blah, 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 a bunch of junk. That's taking pennies from an infinitenaire. That sounds really weird, but imagine, like you're a quadrillion septillionaire, infinitenaire, right? You have infinite money. Well, who cares if you take pennies? I'm still going to have infinite money, right? So that's like crumbs, literal crumbs, indefinitely small crumbs. Okay, anyways, I'm getting ahead of myself. Because that this is infinity and our integral is diverging, right? It's going to infinity because as our function keeps going and going and going and going, the area under the curve is infinite. And therefore, we can say that our series, because this is a sequence of terms, is also going to diverge, right? So divergent here for our indefinite integral, divergent for our series. All right, I hope you guys enjoyed. If you did, please drop a like, comment, and subscribe. I hope that you have a wonderful day.